It's Mr. Kabbalah. This is going to be unit number 8, lesson number 1 on similar right triangles. It's going to be something you need for Algebra 2 if that's what you're going into next year. So let me know if you have any questions, and hopefully it goes well. Enjoy.
Okay, so unit number 8, lesson number 1, EFG is similar to triangle LMN. Find the following ratios expressed as decimals to the nearest hundredth. Show the fraction that leads to your answer. So LM to LN. So I color coded these. Basically, L maps to E, or E maps to L. F maps to M. G maps to N. So LM would be the same as EF. When I say the same, I mean similar to, I should clarify. So LM 12, LN is the same, or corresponds to EG, so that's 13. So that ratio, if we do it on our calculator, it says to the nearest hundredth. So 12 divided by 13.92. Okay, MN would be 5, and LM would be 12. So 5 divided by 12 to the nearest hundredth, 0.42. And then MN would be 5. LN would be 13. .38. So the reason why we did this is to go over the concept that in similar triangles and similar right triangles, the ratio of the sides is going to be the same if you change them to decimals. In fact, you're essentially making this a unit rate. I mean, this one here, 0.92 to 1, I guess, if you want to put it that way, or 0.42 to 1, 0.38 to 1. Those are all kind of like unit rates. And in similar triangles, those unit rates will be the same if you make them decimals or whatever they turn out to be, a unit rate. Okay, so number 2, it is known that triangle RST is similar to triangle WXY, RS18, ST25, TR11, and I drew WXY next to that. It's not going to be to scale, but it's, at least the letters are right. Notice that W maps onto R, X to T, Y to S. So when it's asking us for XY, that actually, I was trying to change color here. Come on. That actually corresponds to, let's see here, XY corresponds to ST, so 25. And then WX corresponds with TR, which is 11. And so if we make that into a ratio and then change that to a decimal, 25 divided by 11 is 2.27, so number 3. Okay, question 3, I already drew these in. I made sure that the letters corresponded, so M maps to Q, N maps to R, P maps to S, and then all of the corresponding sides match up. These don't necessarily look like right triangles. I think they're supposed to, but in any case, what could be used to solve the length for QR? So let's find QR here. QR corresponds with MN, and that's 14. So we could do 14 over X. That's the part we don't know. All right, and then we are given that QS is 7. And you know what? I should actually, so QS maps onto MP. Right, now in my proportion, if I put the 14 on top, then I'd have to put the 16 on top, and then the 7 on the bottom. Right, now if we take a look at our choices, now they're calling X QR. So we need to find the proportion where we multiply QR times 16 and then 14 times 7. So nope, 14 times 7, but we need QR times 16, so it's not that one. 7 times, nope. Let's see here, 7 times 14, yep. QR times 16, yep. So I'm going to go with choice number 4. All right, number 4, 74 inches tall is Justin. He casts a shadow that is 102 inches long. The same time a tree casts a shadow that is 39 feet long. How tall is the tree to the nearest foot? So notice that we have some measurements in inches and some in feet. My first thing is let's get those in the same unit. So 74 divided by 12 inches per foot is 6.16 repeating feet. So just over 6 feet tall. His shadow, 102 divided by 12 is 8.5 feet. All right, so now line equals sign line. This is the part we're trying to figure out. So let's do the height of the person and the tree. So 6.16 repeating compared to x. The shadow, 8.5 feet for the guy, 39 feet for the tree. So I'm going to cross multiply. I'm going to do 39 times 6.16 repeating, and then divide that by 8.5. Now it says to the nearest foot, I got 28.29, which is going to become, rounded to the nearest foot, 28 feet. Katie's trying to determine the height that a ladder reaches as it leans against a wall. She walks under the ladder and touches her forehead to it as shown. That's weird. If her feet are 16 inches from the ladder's base, the ladder's base is 4.5 feet from the bottom of the wall, and Katie is 5 feet 6 inches tall. Then come up with an estimate for how high the ladder reaches up the wall to the nearest tenth of a foot. Watch your units on this problem and show all work. What they mean is, again, some measurements are in inches, some are in feet, and some are in both. But it is asking for our answer to be in feet. So 16 inches is actually 1 foot 4 inches, which is actually 1.25. I'm sorry, not 1.25. 4 inches would be a third of a foot. So that would be 1.3 repeating feet. 5 feet 6 inches wouldn't be 5.6. 6 inches is half of a foot. So that's actually 5.5 feet. And then that's already 4.5 feet. Now it just says to estimate. Now if she's 1.3 feet from the base of the ladder and her height is 5.5 feet, 1.3 times about 4 or 5. Let's start with 4. Does that give us something close to 5.5 feet? Well, that's about 5.2 feet. That's 5.5 feet, so it's close. So if we take 4.5 and do the same times 4, again, just an estimate, we get that this should be about 18 feet. Now, if we do it times 5, 1.3 repeating roughly times 5 is 6.5, so a little taller than, what's her name, Katie. So 4.5 times 5, again, just an estimate, that I think is 22.5. Yeah. So I would say it's going to reach anywhere from 18 feet to 22.5 feet above the ground. Now, what might be some factors that would cause error in your estimate? Now, I think it says problem 6. I think they mean problem number 5. List as many as you can. How does, I guess one thing, I'm not going to write them down, but how does she know that she's exactly 16 inches? How does she know she's exactly 5 feet 6 inches? How does she know the base of the ladder is 4.5 feet? The ground might be uneven. She might be overestimating, something like things like that. Okay, there's always human error whenever measurements are taken. All right, number 7, the last one. We've got coordinates. AD and BE are parallel because they are both horizontal. What does this tell you about angle BAD and CBE? That would tell me that they are both congruent or equal. And I would say something like the slope creates two equal angles or something like that. Why must triangle BAD be similar to triangle CBE? Well, if we just said that one angle is the same and then they both have a 90-degree angle, if you have triangles that have two angles that are the same, then you have similar triangles. So this is what we'd call angle-angle similarity. And if you think about it, triangles can have all the same angles, but have different side lengths. And that's because the angles in a triangle have to add up to 180 degrees. So they can be the same angles, but have different sizes. All right, down here we have to find the slope of AB. So I already set it up 3, up 2, so a slope of 2 over 3. For this one, this is up 9, this is up 6, which does reduce to, guess what, the same thing, 2 over 3. Given your answer in B, why does it now make sense that the two slopes in C are equal? I would say something like, because it's rise over run, or it's vertical over horizontal distance, and we have similar triangles, then these are going to be in the same ratio. So same ratio because we have two triangles that are similar. Okay, something like that. Hopefully this is a help. Let me know if you have any questions, and hopefully we'll see you soon. Bye now.